Hello everyone. So today we will have a look at the uh, very recent problem called racing from the code forces round 1026 div 2. Right. Okay. So let's first try to understand the problem statement. So mainly it's basically that you are flying a drone, right? And you have certain obstacles. So you have n obstacles and you have their heights from like uh, like you have a drone height that is given by hi for each of these obstacles, and you also have li and ri indicating the heights of the obstacles, right? So if I just show you an example, before that you also have an array called di. So di is given as hi minus 1, right? So it is the height and difference of the drones between the ith one and the I minus 1th one, right? Okay. So let's just look at a test case. So uh, a very recent test case is 0 4 1 2 2 4 and 1 4. So if you have a look at this test case, okay, and your initial height is given as 0, right? So your hi is 0. uh, Now the point is, let's just try to understand this particular example. So this is 0, this is 4, then this is 1, and this is 2, and let's just make 2 a bit above this. So let's say 2 is here, and then you will have 2 here and 4 here and 1 here and 4 here, right? So this is the height of the, this is the height in which the drone must be there, right? So initially you are starting from the 0th position, right? So where can you go to? You can go to the first position, right? So uh, the problem says that you can make only two kind of jumps, right? One is that you stay at your position, right? And the second is that you just go one step above, right? So basically this array di, this will contain either 0 or this will contain 1, right? And the other thing that it might contain is minus 1. So minus 1 indicates that at that particular place you don't know what to do, you have to tell me what to do, right? And you have to tell me that you have to put optimal things here so that you can complete this whole, this drone journey. You have to complete this, right? Okay. So the point is that in all these minus 1 places, uh, you will put certain values. You can put either 0 or you can put 1, and you have to complete your drone journey, right? So your di can be either 0 or it can be 1. That is your d array, right? So as I was looking at this example, so 0 4 1 2 2 4 and 1 4. So the allowable like the allowable uh, distance is from 0 to 4, and you can go from 0 to 1, right? You can't go above that because you are either allowed to go one step above or you are allowed to stay at the same height. And initially you are at height 0, so 0 1. So what you will do is you will just take the intersection, right? That 0 4 is the allowable interval and 0 1 is your uh, like the possible interval, right? The maximum possible interval, right? So what you can understand from here is, as 0 1 is the maximum possible interval, so now see 0 4 makes no sense because and when will it be possible to uh, like complete this particular journey? That will only happen when your possible interval and your allowed interval, you know this both need to have some intersection. In this case the intersection is 0 comma 1, right? In this case the intersection is 0 comma 1, so there exists some intersection. So what we will do is, if there's minus 1 present in the array, right? If there's minus 1 present in the array, we will simply update, right? We will update the values of L and R, right? So in this case your D array, is given as 0 minus 1 minus 1 and minus 1, right? And let's make it again. So uh, so what does 0 mean? 0 mean that you're staying at height 0, right? Okay. So let's for the time being ignore that. So here we have 0, here we have 4, here we have 1, here we have 2, here we have 2, here we have 4, and here we have 1, and here we have 4, right? Okay, so as I said, you can go to 0 comma 1, and the intersection is 0 comma 1. Okay, so next time what can you do? Next time you can go one step upwards, or you can stay here. So the next allowed interval is going to be, like, the maximum possible interval, it's going to be 0 comma 2, and you're allowed 1 comma 2. So what is the intersection? Your intersection is 1 comma 2. Now see, if anywhere intersection, if it doesn't exist, right, if there's no overlap, then you will simply return no, that I can't complete my drone process, right? But otherwise you're going to do it this way, right? So I'm just saving these values. I'll save that in some last array or some any array I can take, and I will keep saving these values. Okay, so now I got 1 comma 2. Now my next interval is 1 comma 2. Now the next after updation, what is going to be my 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 maximum possible interval? That is going to be 1 comma 3, right? And what is my given interval? It's 2 comma 4. So what is the intersection? The intersection is 2 comma 3. So now you are at 2 comma 3, that's for sure, right? Because whenever we will find whatever intersection we will find, we will simply update that particular intersection, right? Okay, so now we are at 2 comma 3. Now here I can go till 2 comma 4, and my allowable interval is 1 comma 4. So I can simply so my last overlap is basically 2 comma 4 only, right? I have to stay somewhere between, like I will stay somewhere between this, right? So I've kept all these values, all these updations in a particular array. And now what I'll do, so now see, if I've gone till the end, and I have always found some or the other overlap, what does that mean? That it's definitely possible, but I need to print the answer, right? I need to print you the sequence, that what do I need to put in, like the resolved D array having 0 1, so all the minus ones must be replaced with either 0 or 1. So for that, now see, I know that I'm ending at 2 comma 4, that much I know, right? So I can simply backtrack, because I've already saved that for each index what is my overlap, right? I've already saved the values of L comma R, right? So what you will do is, if your di is 0, if your di is given as 0, what does that mean? That there's no updation required. So this thing, you if you don't write, then also it's fine. But if your di is equal to 1, and you have some particular value of L and R previously, so you'll just update. So you'll do L plus plus and R plus plus, right? You'll just update, right? Okay. The next part is if di is equal to minus 1. So what you will do? So if di is equal to minus 1, if di is equal to minus 1, then what you will do is equal to. So if di is equal to minus 1, then we'll simply update the values of L comma R. So L comma R will be my overlap. So whatever is the overlap between L comma R, and how do you find the overlap? The overlap is simple. I'll just teach you a concept. So if you have L1 and R1, and if you have L2 and R2, when does an overlap exist? An overlap exists when the maximum of L1 comma L2 is less than, when the maximum of L1 comma L2 is less than your minimum of R1 comma R2, right? Like in this case, L2, which is the maximum of L1 comma L2, this has to be less than your minimum of R1 comma R2, which is R1 in this case, and this is clearly lesser, right? L2 in this case is clearly lesser than R1. That is completely visible, right? So then only an overlap could exist, right? So in that way you can find the overlaps. So an L comma R has to be updated according to that overlap. So the overlap is between your maximum possible sequence, right? Your maximum possible sequence and your it is between the maximum possible sequence and your allowable sequence, your allowable interval, right? Okay. And now how to backtrack? So I'll show that taking the same example. So now see, you have 0 4, you have 1 2, and you have 1 3, I guess. Let me check. I have okay, I have 2 4. So you have 2 4, I have 2 4, and I have 1 4. I have 1 4, right? I have 1 4. Okay. So what to do in this case? Uh, so I know the maximum. I'm ending at 2 comma 4. That thing I found, right? We have already seen that. So as I'm ending at 2 comma 4, I'll take this 4, right? And now I'll see that what is the last updated interval. So in this case, if you remember, the updated interval was 2 comma 3. What does it mean? That I need to jump to one level, right? So basically this will be 1, right? Okay. So now your allowable interval is 2 comma 3, right? And the what was this interval? If you remember, this was 1 comma 2. That means I again need to jump. So now you're at 1 comma 2, right? You're at 2 basically. And what is your allowable interval here? It was this one. It was 0 comma 1. It was 0 comma 1. That means you again need to jump, right? So you can simply write 0 1 1 1. This is going to be your output. So I believe you have understood how to backtrack. It's pretty simple. So the backtracking concept is just that if I need to jump, I'll check if I need to jump. If I am okay without jumping, so like if like here the allowable interval is 2 comma 3, if the allowable interval in this case was 2 comma 4 and I'm okay without jumping, then I'll continue to be at that particular height, right? And if I'm not okay, if I have to jump, then I'll simply return 1, and if I'm okay without jumping, then I'll return 0. That's it. I hope you have understood this question. So thank you.